Hi, welcome to the video for the Unit 1 project. Let me just go back to the main page so you can see how to access the project. We're in Unit 1. The project was issued in week 2 on Friday. So when you open up the project document, the first thing you want to do is you want to take a moment to read through it for yourself so you have a sense of what the project's all about. So if you need to pause this video to do that, make sure you do that now. Okay, at the top you'll see the due dates. There's a first draft that'll be due on Friday, February 19th. So I can give you all feedback, and then a final draft due a week later, February 26th. So what do you need to do for this project? First of all, before I tell you what you need to do, let me tell you what I will be looking for. Essentially, I'm looking to see your understanding of the types of nuclear reactions like fusion, fission, alpha, beta decay, etc. Like, can you identify them? Also, can you balance nuclear reactions? And your understanding of how nuclear reactions are related to the stability of a nucleus. So if you have a spontaneous nuclear reaction, one that happens on its own, that means the nucleus is unstable, and depending on what's causing that nucleus to be unstable, can undergo certain types of decay or reactions. So those are sort of things that I'm looking for you to show. And I guess also the flip side of that, if you're doing a fusion reaction, will your product be stable? And that again will be based on your understanding of nuclear stability. So in this project, you're going to convert one of the base metals. If you go down to the second page, you'll see them there. So base metals are just cheaper metals: zinc, nickel, iron, lead, or tin, into gold. So you need to choose whether or not you're going to, which one you want to do. So let's say, for example, you decide you want to do iron. Okay. The third step is to pick the most abundant isotope of iron. And you go to this website here, you open it up. It'll take you to, this one starts on at nickel, so information here for nickel, but we need iron. So to get to iron, you would scroll down until you find iron. There we go. And when we're looking for the most abundant isotope, remember that elements can have more than one naturally occurring isotope. So if you were to gather all the iron atoms that are on Earth, some of them will be iron 54, some 56, some iron 57, and some iron 58. But which isotope of iron will be the most abundant? Well, the percent abundance is in this third column here, and you can see here 91.754% iron 56. So this will be the isotope of iron that you're going to start with. So if you choose to do iron, you would take iron 56 and you want to convert it to the most abundant isotope of gold, which if you were to look using this, it'll tell you what the most abundant isotope of gold is. I believe it's gold 197. So then your job would be to go from iron 56 to gold 197. Now, what are some of the constraints that we have for this project? Okay. So the constraints are you have to convert from iron 56 to gold 197 in 7 steps. Okay, so you can't just do it all in one fell swoop, just add the right number of neutrons and protons and be like, boom, I got gold 197. No, you need to do it in 7 steps at least. You could use more, but you can't use less. And then of the 7 steps, you need to have at least 1 fusion, 1 fission, 1 alpha decay, 1 beta decay, and 1 gamma decay. Now, of course, you can have 3 fusions if you want, as long as you have one of each of the others. So you can double up, but you have to have at least one of each type of reaction. Now, there are also reactions, remember we talked about transmutation, where you have a nuclear reaction is taking place, but it doesn't classify as fusion, fission, alpha, beta, or gamma decay. It's just transmutation. So you could have things like that as well, but you have to have at least one of the 5 types of reactions we studied. once you've created your mechanism, then you will you can write that in this document or present it in on a poster or a Google slide, however you want. If you want it, you can put the mechanism here. Now, a lot of people are like, well, what does that look like? Let's back up for step 4. What does that look like? So I'm going to show you an example. It's not quite what you ought to do because this person did the reaction in only 3 steps, not 7, but it gives you a sense of what I'm looking for. So here's an example of a mechanism that a student did last year, and this student used copper 63. Now you all cannot use copper 63, but you can use any other type of the base metal, so like the zinc, the nickel, whatever. So copper 63 to gold 197, and they did in 3 steps. You need to do it in 7, but as you can see, for each step, what they did was first they started off with copper 63, and they did a fusion reaction with phosphorus 31. So they fused them together to create a larger nucleus. This is xenon 94. And then they took what they got from that first step, xenon 94, moved down to the second step, and then they did a fusion with xenon 94 and manganese 55. Combined those together. And then they created gold 149. And then they took gold 149 and bombarded it with a bunch of neutrons, which added a bunch of neutrons to it, and got gold. From there, they got gold 197. They added 48 neutrons. So essentially, this is 48 separate steps. All right. Now, this is not 100% completely correct. For example, this is not a neutron emission. Emission means that the neutrons would be on the opposite side. It would be a product. You're not adding it to the gold. I guess this would be called a neutron capture because the gold 194 is capturing those neutrons. So the name of this is wrong. Also, unlike for you all, this person only used 3 steps. You will need to use 7 steps. And they only have fusion here. They're missing alpha decay, beta decay, gamma decay, and fission. And the reason why the students' work was very different from yours is the rules were different at the time when I initially gave this assignment. So you all have a bit more of a challenge. You're doing 7 steps, and you have to have a fusion, a fission, alpha, beta, gamma decay. But it gives you a sense of what a mechanism looks like. So your first step, you're creating a product, and that product you create in the first step could be used in the second step, and so on. Now, if you have a step where you create 2 products, you don't have to use both of the products in that step. For the subsequent step, you can use the product that you want. So that is also a possibility. Okay, so now that you see what the mechanism looks like, you can present it as a poster like we saw in the previous example, or just type it up in here in your document. After that, you have some reflection questions to answer, and then you would just submit it. Now, one thing that I kind of skipped was this first step, is if you are doing this with a group, you cannot have more than 4, and your group, you must be able to explain what each person did in the group, because remember, I'm trying to gauge your understanding. However, I also think that this is a good reaction to collaborate on, especially when it comes down to figuring out steps and discussing that as we've done in class. So that's the reason why I'm opening it up for group work. But you know, essentially, you could do this on your own if you wanted to as well. It's totally up to you. Final thing, this part in the front here, the overall reaction, you do not have to do this. If we were doing this whole class and I was modeling it, I would give you sort of that information. But you can just skip this. I will not be checking this. The only thing I'll be checking is your mechanism, your reflection questions, and if you're doing it in a group, I'll be making sure you have your contributions all outlined. All right, final thing. So to get you all started, in terms of if you're deciding to pick a group or not, there is this project survey, and it'll be linked in the same message where this video is. In this project survey, I'm asking you to tell me how you plan on working independently or with a partner or a group, and if you're not sure. And if you are interested in working in a group but you don't have anyone, I also have that as an answer as well, because if there's a group of students who want to work in a group, but they don't have anyone that they can work with, then I can hook you all up together. Just let you know that there are other folks who are interested. But please make sure you fill out this survey so then that way I can help with their group. All right, I hope this video was helpful and clarified some things for you. Other than that, I hope you all have a quality day, quality weekend. All right, take care.